Right, just need to make sure there's no.
And we are
It's telling me that.
live.
Yeah, there's more information now. It tells me that it's going to Twitch and it's live. Yes.
All right.
And so I have an AI companion.
Oh yeah. Okay. Cool. Oh no. Oh. Okay.
Hello, everyone.
Mm.
We are back.
What's a vengeance?
With a vengeance, with some new content for you. Exciting, fun content.
No more boring proofs, only fun content.
Yes.
No, we still love proofs, but we thought we'd make some games, which would be weird to do in a proof assistant, but not the first time it's been done.
Isn't it? Oh, okay.
Well, I'm guessing Idris has done it, right?
This is a very good point. So one of the motivations for this is like Edwin Brady says that even a proof assistant language should be Pacman complete. So you don't want to be Turing complete, that's bad. You want to be Pacman complete, that's good. Now I don't know if Idris is actually Pacman complete or not.
Oh, okay. Okay, so he just said this. And
he
then
said it as an aspiration.
Okay.
But I think like it seems like you could have Raylib bindings for Idris, and but maybe no one's actually done it yet. So
yeah, and I think since it should, yeah, it should be fine. But I mean, if you're in the IO monad, aren't you Turing complete at that point?
So yeah, but Idris has ways around this. So totality for Idris, so it means that your program has to make some progress like within a certain amount of time. So there's a way of making this precise. So you can have like you can have like you can have stuff that runs forever, like in theory. But
okay.
So that it's broad. The definition of totality is broad enough to encompass even Pacman, I think.
Okay.
So, but
right,
I don't know if it's been done or not.
Let's brush.
I'm very confident we could do it in Lean. I'm
Yes.
very confident that Lean is Pacman complete. Well, it could be Pacman complete.
Yes.
That would be a proof if we wrote Pacman. That would cover the proof part.
Yeah. Yes. Yes. Then it is inhabited.
It's like a meta proof. It's not a proof in Lean. Although you could write a proof in Lean and inhabited by Pacman.
Yes.
Yeah.
Yes. That's what I'm saying. I think we can just assume this in the real world. But if there is a Pacman in Lean, then the proof is inhabited, so it is a proof.
Yeah, but then can you express that in Lean? Like in the type system, you could put Pacman in the like a description of Pacman in the type system.
Yes. Okay, that'll be the final.
So, yeah.
The final episode. Spoiler
before
alert.
you retire.
Spoiler alert. That's where we're going.
Season 25.
Yes. Okay.
Hello, Max.
But you've made some games. Maybe we first look at what is working.
Yeah, let's look at some games.
And then work backwards to how it's been done.
Yes. So we have so yeah, this is maybe I should point some stuff.
So before you were talking about whether you could run
hi Max.
Pacman in the type system.
Yes.
You could trivially, because types can mention values in Lean.
Right. Let's do it then. See how trivial it is.
Yes.
Okay, so this is the repository that we're working in, RayLean, and the name is a pun, as it should be, although I wasn't aware of it. So this is Walter.
Well, it's a combination of Raylib, which is the C bindings we're using, and Lean.
Yes,
It's
that's very important. Is this we're going to be using this this library, which is a C library, and it's for having fun, which is what we want to do.
Yeah.
So it's for adventurers. You enjoy things. Are you ready to enjoy coding? Are you ready for that?
It's been so long.
It's been so long. So yeah, so this project has bindings, and then it has a few other nice things. So maybe we start with basic window.
Oh, nice.
So this is not really a game, but it shows that you could, this is a
it shows
yeah,
it
just
make things
shows
flicker.
you can run something. Yes, you can make things flicker and
also draw SVG.
Oh yeah, that's right. This one is this is an SVG.
No.
So right. So where should we go next?
2D platformer.
Oh, 2D platformer. Okay. So we have yeah.
Yeah. That is a PNG, right? So
that is a PNG captured from WhatsApp. Yes.
Yes. So there's no transparency.
No, it's and if you this again, this is not really a game because there's no you can infinitely fall and there's no consequences. Although at some point you don't know you're falling anymore because there's no the universe has no reference points. So
can you still look now?
No. Well, yes, you can, but you can zoom in.
Okay.
But you're essentially the camera is locked onto the camera's moving with you.
Arguably, the consequences of falling are much more severe in this game.
Yeah. Yes. Yeah, that's true.
Very good point. Yeah, actually, that's very scary.
Okay. And yeah, there's 3D.
Yeah, I still can't believe this thing can do 3D. Like,
yeah. And what else have we got? Yes. Jessica can't swim. Let's see. What's your high score? This is the only game which is actually a game.
Okay, so
so far.
The best thing to do, the best strategy is to leave it and just go away for like half an hour. And then just,
so maybe
pick up all the shells that have been generated. Like that's you get a high score.
This is the optimal strategy. Okay.
Yes. Pick up those, but not touch the blue. Like the blue is the ocean, it's trying to catch you. And the red is the wet sand.
Oh, look at this.
On that.
52 points. I've never had this many.
The ocean comes back at a random speed. It always gets you. Like
this is actually a good game.
Yeah,
yes,
you have to be patient. It's a game of patience. Like that's the
Oh, I'm not dead. Oh, this is great.
The game is over. Like I think can you still get points?
Over.
I think no, you can't get points.
Good.
So,
this is great.
Just an unfeeling ghost at this point.
Yeah. But you still pick up things. You just don't.
Yeah, you can still. Wow, look how many there are.
Yeah.
I meant feeling in the emotional sense. Like she can pick them up, but it means nothing to her.
Yes, exactly.
And then we have. Then I've been working on thought of something called an entity component system framework, which sounds just it's a ridiculous word salad.
Yes.
But it's actually quite interesting.
Component factory worker.
Yeah. So we have this as well, which is not really a game. So
Beautiful.
We're orbiting, but you can the green one you can modify the velocity, and so yeah, so you can do orbital mechanics.
So can you move the green one, or?
Yes, I'm moving the green one with the arrow keys now. So I have infinite fuel, so I can do stuff like this. But normally you can't do that.
Okay.
But yeah, so this thing in the center just like a massive object, and then these blue ones are just yeah. These blue ones are affected by the inadequacy of floating point.
Okay.
Which is why they do random things. Yes. And then I can do reset and can reset the thing. So this is using the entity component system.
Oh.
So they told me Lean would be easy, but this doesn't even use dependent types and it's rocket science.
Yeah. Well, this does use dependent types.
Oh, so really? Where'd you use them in your rocket science?
In the entity component system. So it's this magical thing which I'll show you later. But we actually,
which does
that was based on the paper you shared.
Yeah, exactly. It's based on this. I can't find the link to the paper now, but yeah, we'll discuss that. But and then there's one other one.
It's in the Discord. Anyone who wants can join the Discord.
So that I made this one as well to show off more of the entity component system features.
It's delightful.
Yeah. So yeah. So that's where we're at, and I don't know if we covered.
I think that's all the games we have.
Yeah, that's all the games, but this.
This is the bindings, right?
Yeah, these are the bindings to Raylib, and I don't know, maybe have 10% coverage of the bindings. I just add them as we go, as we need them.
Nice.
Yes, and there was a massive memory leak in the Orbital one, which I fixed. So you need to use this thing. So this is like borrowing.
Oh, okay.
There's some because there's all this reference counting which we have to keep track of. But if your binding function doesn't hold on to this, then you can use this borrowing thing, and you don't need to use reference counting, and it doesn't leak. So you just need to remember to use that everywhere that you have like a non-primitive type, and then
because you're the creator of the object, so you're like relying on Lean to free it, and you don't want.
Yes, exactly. So what you could do is you could just when you consume this, you could dereference the count. Sorry, decrement the reference count. Dereference decrement the reference count. Yes, or you can use this as long as you don't pass it to anything that expects to own it.
Yes. Yeah.
So there's one exception here, which is this one here. So
update camera.
Yeah, so you get the same object back, and all return values are owned. So you have to not use borrowing here.
Okay.
Otherwise, things can go wrong. But all the others are. Yes, and there's also a project which I want to use. It's called Alloy, but it's not that Alloy, Max.
I got excited.
Different Alloy. Yeah. So it's actually because Lean has this wonderful metaprogramming system, and what this project allows you to do is write your C bindings in Lean, so you don't need to write them in C. So yeah, this would be great. I think this this fellow here is part of the Lean core team, I think, or
yes,
I'm not sure. Yeah. So yeah, that's something I want to try out. So,
Cool.
okay, so where should we? So yeah, the aims of this stream is
I think maybe
the aim of this stream to have fun, and then we need more specific aims. That
I think maybe just starting to show the 2D platformer, just to give, because you showed a bit of the bindings, but maybe just like
yeah,
some of the like really basics, just to
maybe we can start here.
Catch up first.
Yeah, exactly. So we have so there are certain things you have to do as a Raylib program.
Right?
Yeah, this is the whole. This is not the platformer. This is the one that just shows you the window. So it's like even
the window
basic one. Yeah,
okay.
The window one. And so what you must do, you must call this function init window, and you give it screen width, screen height, and sort of like a label. And then this is the game loop here.
Okay.
So you write it as an explicit loop. There's no like fancy event loop that you've got to hook into. You just and then Lean, you can do the while loop here.
Yeah,
and you check that.
Raylib is quite it feels like quite against owning the game loop, and I think that's like why they're struggling to add iOS support, for example, like because the iOS libraries all own the game loop, so yeah, that's causing a bit of tension there.
Right.
Yeah.
And so but for us, it's quite nice because we don't need, there's nothing fancy here. This is just a normal Lean loop, and Lean has these while loops.
I forget this every time. I know it has for loops, but I mean, no. Did I know it has a while loop? Like, I don't know. Wow. Okay.
Yeah, the sugar in do is very. We'll see. I mean, we can do mutation in a do as well, which is very nice.
Yeah.
It gets desugared to some like state monad thingy, but. So yeah, when you call this, you must call this render frame, and you give it a function. And in here, you can do. You do everything for rendering. So this has the. Yeah, so it's very like procedural. So you call this begin drawing and end drawing, and then you do all your rendering stuff in between those calls.
Cool.
But that's basically it. And so you do your updates to your state or whatever outside of this rendering part. So the general flow is that you do this while loop, you do some updates, and then you do the rendering. But this is like happening. So you shouldn't do very expensive things in this render block.
Okay.
So would you put the random number generation outside the block then?
Yeah. Exactly. This is not the best.
Maybe that's why it's only 59 frames per second. I was wondering, like, what's stopping that from being 60?
No. We can. Oh yeah, but there's some issue with iOS, I think. But I can just make it 1,000 or something.
Oh
I can just so this one. Let's see what if I don't set a target FPS.
I think you removed it by accident.
No. I can remove it. I want to see what the.
Oh, okay.
Oh no! Hold on a second. What?
Maybe just
it probably has a default.
Okay, let's see. Did I press the wrong one? Oh, there we go. 700.
You've transcended 59 frames per second.
Yeah. Yes. Nice. So 60, especially if you're doing animation and stuff, you have to restrict this to some number. Yes, and so we also have support for loading images from And I did a very self-indulgent thing of like some weird way of embedding the resources into the executable, so we can just load them from the binary by name.
Nice.
Really
That's
nice.
not so. So yeah, yeah.
I love
So
that.
it generates. Oh, there's nothing in here. Where is it?
The wrong bundle.
Yeah, where is it?
Maybe in the C. It's in the C.
Yeah, I think because it's git ignored. I think it.
Ah.
Where does it end up? I don't remember. Oh, here we go. Yeah. So it reads, and it's a lean script. It's a lean script. It reads all the data, and you include this file, and it's just statically in the executable, and then you just have a binding that you just do a C string comparison, and it says, well, and then you read out the bytes. You don't need anything fancy. This is but this means you can ship the binary, and you don't need any like external resource directories.
Yeah,
and
very.
you can do it. You can do this in Lean. So
that's
where is it?
Like this is very common to do in Go, just to make things easier to ship. So I'm happy to see this again.
Yeah. So look at this horrible.
Ouch.
I'm generating C from.
You're so cool.
Okay. Okay. Wow. I was
so
happy.
We don't have. Yeah. So this is. I love it because it's so bad.
Yeah.
Yes. So we can just generate out C. Okay, and then there's no function to do hex encode. So.
Nice.
This is having fun, right?
Yeah, this is definitely having fun. Yeah.
Did it feel cool writing unsafe? What does that do?
Oh, unsafe. Because it can't. I think it's the. I think this is the termination checking. It doesn't know that this terminates, which is fair enough.
Like, you shouldn't need it here. That's kind of. But yeah, you were just having fun. But we should. We should look to remove these one day.
Yeah. But it was nice. So Lean has all the facilities for doing I/O, reading bytes. There's all this kind of low-level stuff. You can do it, read a binary file and path manipulation and so on.
Code. Like
you can't hex encode. Look, I didn't need to hex encode it. I could have just left it as decimals, but I wanted it to line up. Columns. God. So.
I mean, the generated C looks beautiful. Like the code to generate the C looks awful, but like the result is great.
Yeah, result is nice. Yes. But, okay.
Oh, well done. Well done.
So, so from doing this, and there's a flag, so you can switch it off. So you can load. Say you wanted to just be in debug mode and just change the assets on the fly. You can switch that off, and it will just load it from the file system.
Okay.
There's a config flag for that.
Which I will never use. Thanks.
Yeah. Well, I mean, if you were like, I don't know, maybe we'll do hot reloading. So.
I mean, maybe.
I won't. I mean, we have access to C, right? So we can just do like dynamic library. We can compile the thing to a dynamic library and then reload the dynamic library.
That does not
get hot reloading.
That does not sound fun.
Hot reloading is great when it works. Implementing it does sound like work, but
and debugging it, and then wondering like, is it hot loaded now, or is that what? Which did I save? Did I recompile? Did I? And then it just makes me crazy.
I don't know. I've worked in environments with it and it worked very well. But those were environments where you really wanted to avoid compiling because it took longer than 2 seconds. It looks like this takes about 2 seconds.
Yeah. And we compile like the Raylib dependency and the other dependencies as well. So the Raylib itself is very fast, but that's because it's C. Anyway. Yeah, we got sidetracked with that.
I think you can.
I just want to point out that this is so nice, not having to bind.
Yes.
You can bind like this without giving it a name in the do.
Mm. Yeah, usually people do
very
this
nice.
with like a fish or reverse fish operator, right? But
in Haskell, you can't do this even with the. Oh, I see what you mean. Yes. So.
But this feels more
natural.
Yeah. Like
yeah. Because you're sort of passing it in the right order.
Yeah. This is easier to reason about because you just go like, just take it out of the monad, like, and then pass it as a normal parameter, and let the do notation desugaring figure out what it should have done. Yeah. But since you're on the image, it might be good to just mention the re-SVG library.
Oh, that's right. Yeah. So there are issues with the.
But like.
Yeah. There are issues with the SVG support in Raylib.
Yeah.
And it's because Raylib has its reasons. It wants to be small, so it wants like header-only libraries, and it uses a header-only library for SVGs, but it doesn't support like the whole SVG standard. So we're using a separate dependency.
And actually, the SVG standard is much larger than you think it would be.
It includes JavaScript.
Oh dear.
Okay, didn't know that.
You can have JavaScript and CSS in your SVG. I'm pretty sure it's, almost an HTML document. Like.
Oh, I didn't know that. I didn't want to know that.
Yeah.
It's not like
maybe this library
is going to run JavaScript for you. Like.
Did we just open up a security hole? Is this what happened? Like.
Yeah. Yes. Anyway, it's written in Rust, so it is safe. So we don't have to worry about security issues. Yes.
Oh, thanks. That was good. I think going down is pretty cool. There's there's some graph. Yeah. This is
cool.
Yeah.
These graph. Yeah. I mean.
So it is better support for SVGs than Chrome.
Yes.
That's insane.
Because how much JavaScript do you want in your SVG, really? That's.
Yeah.
Oh, there's something it doesn't support. Oh, right. It doesn't. It only supports Unicode. So that was one they. Yes.
Okay, that's fair.
Yeah.
And
no animations. We can't have animations, but it doesn't say no JavaScript. So.
Yep, there. No a script view or cursor.
Oh. Cursor.
Only static SVGs. So yeah, there.
Aha.
Yeah.
No script.
Mm.
Yeah, seems sensible.
Yeah.
No events, no animations. Yes. But what's really nice is they provide like a C thing, so we can just call it a C API. That's very nice of them. So we can just call into it from our bindings. So we just need some graphics now. There's someone to, because I can't do that part.
Yeah. But we're ready. We're ready.
We're ready for input of data.
Yes.
I can't draw anything.
Yeah.
Okay. So
maybe the platformer is nice to show with the input keys.
Oh yeah, so input key. Well, we've got the platformer. The platformer example uses this is so we have several different games with different strategies. So this one uses a monads, like a game monad, but not really.
Yeah, I forgot about this. Yeah, but
yeah.
like,
well, also using lenses, so it's just like,
yeah,
I'll just implement a lens library.
we're having fun. So like,
Yeah.
we
So,
well, you haven't written any games. I haven't written games in 20 years plus. So we don't know what we're doing. So we're trying a few strategies out.
yes.
So the game monad is one, the entity component system is another, and just a bunch of state machines is the other one. I'm like more of a Elm-like thing is what I'm trying.
Yeah, so this shows you like how the instance stuff works, and yeah, so okay. This has update functions for the different things, and has a reader that stores like the texture and initial, like where all the I'll just remind what the platformer has. So it has yeah, so these obstacles are kind of hard coded in the reader when you launch the thing, so they don't change. And then we've got some state, which is like the position of the character and so on.
Cool.
And so yeah, we update. We need to check. We can probably do this better now. Yeah, so we can do things like, is the key down? Then we modify the position. So we can check for where keys are down or where the mouse is down. We're missing like things like, is key pressed? And there's a difference between down and pressed and so on. But that's all covered by Raylib. And yeah, and then there's also like some APIs for dealing with collisions, so you don't have to do this comparison business.
But yeah, we're new to game development and using Raylib, so yeah.
Yeah.
I
and then this is
been worse than this that I did. So
okay. Yeah, so I did reach some limit here, which was interesting. So you
is an obstacle like an abstract obstacle? Are you using lots of abstraction?
Did I call an obstacle somewhere?
Where?
Oh yeah, here we go.
Is that lens terminology?
Yeah, it is. It's like oh, hopefully we can get that in somewhere. Like we abstract the game engine and we have obstacles. Yeah,
I love it.
Oh yeah, this is somewhat interesting. So say you're in a scenario where that because for loops in a do notation have a early return, which is really nice in Lean. However, it doesn't work it doesn't work in some circumstances. So this is one way around it. Say you're in some weird situation like this where the early return doesn't work, then you can wrap your thing in an option T, and then failure just which is one of alternative type class will cause an early return. So this is good.
Interesting. So option implements the alternative type.
And then you can say failure. And so you see what I'm doing here. I'm saying I'm going all over the items, and I just want to find the item that's blocking, and then do something. And then I don't want to check any more items. And so I can use this here. I don't know whether it's good or not, but this is because I'm doing because I have this set position here, or there's some reason why the for doesn't work here. And this is what the for does under the hood, I think.
Okay.
So you can do this manually.
Can I just see the alternative type class again? That was kind of
sure. Yeah.
Or else. Fail or else.
Yeah.
Okay. Interesting. Okay. No, I'll take a look at this later. That's interesting.
Because this is a lot of stuff gets passed in like this because it's not lazy. So in Haskell, this would just be like F alpha. But because it's I think it's because it's eager, then you usually a lot of stuff gets this pattern. Yeah. So if you ever see that, it's because of the of eager evaluation.
Okay.
Yeah,
I'll pick it out later. That's wasn't as obvious as I thought it would be. So
yeah,
I'll come back to this.
So I think or else is just this thing, but this is just defined somewhere.
It's just FA to FA to FA if you think about it as lazy.
Exactly. Yeah, that's in Haskell. It's FA to FA to FA, but you have to. So I know you'll see this elsewhere as well. And they don't always say why, and so, but yeah, if you see this, then it's like because yeah.
This is just technically a monoid, but the right side is lazy. Yeah, that makes sense for alternative. Yeah. Okay. Thanks.
Right. Okay. So I can. Do you want to talk about the Jessica?
Okay. Yeah.
Jessica can't swim.
Yeah. So Jessica is supposed to, like, except for this file, this is where all the mess happens. Everything else is supposed to be only functional programming. Like, this is all IO and Raylib, and nowhere else does it use Raylib. So that's why there's all these weird. I still have to clean up this file, but let's go to the game. The game.init. If you can jump to that, that's also fine.
This one?
Yeah, that's good. So here, you have a bunch of stuff like weight send and shells and the player. And so you need to initialize them in init. And then when you get some message, you have to update everything with that message. So that's the update function. And then you need to be able to view everything, which just returns a list of things to draw. And the weird part is this emit function. So things can emit things like their position, or mostly their position. So let's just go to, I guess, ocean.
I just want to point this out. This is
the
mutation is, so you can do this. This is quite common. So you don't have to think about how this is implemented. You can say, this is mutable. I'm going to do some stuff in the for loop.
This is me too lazy to write a fold, and because like there's not.
No one wants to write a fold.
Yeah, and what's nice is now, because of this do syntax, the most popular monad is the ID monad for me.
Yeah.
So the identity monad is now my favorite monad because I just write for loops in it, and I still have pure code.
Yeah.
Which, I really do.
So this one is ID game, but do you do ID run and then do?
Oh, you don't need
Is that how you? So you can do it like that.
Oh, interesting.
If you don't, I don't know why. You may be using the fact that it's ID somewhere, but you can just do this.
No. Oh, nice. I'll do that from now on. Thanks.
So you never have to think about the caller doesn't have to know it's a monad at all.
It's pretty cool that the type system throws the IDs away.
Interesting.
But I prefer what you just showed, so I'll do that from now on.
Oh, they probably implemented subtype for it.
Maybe. I don't know.
Yeah. I don't know where to look, but
I'll do
ID magic here.
No, like I'm happy.
Yeah, but this your ID.run will get rid of it, but it must be doing something else. Yeah, anyway.
Okay.
And so you wanted to look at ocean?
Yeah. So
okay, so how are these events? Who
Yeah,
consumes the events that are emitted? How are they?
well, let's first go to update, just to
Okay.
in this file.
Yeah.
So yeah, so we're getting time events because like every few frames, every frame the time changes. So
Yeah.
get the time event, we move the ocean by a certain amount, and that's just based on like its current state, like the gravity and its speed and stuff like that. And then at some point, when we reach a 0 speed, given our gravity, we start pulling back. Right. So if we go up to emit.
Yeah.
Yeah. So here we'll see. We're emitting our bounds. So that's the bounds message with just the box that is the ocean and our ID, so that other people can check collisions against us. And then we might be pulling back. So we create a pulling back message just in case. And so if our speed is less than 0 and we haven't pulled back already, then we emit our bounds and a pullback message. Otherwise, we emit just our bounds. And then we will receive our own message later if you go back to update.
Yeah.
And we're just like, don't emit this again. So that's what already pulled back on line 56, 57 just sets it to true so that we don't say we're pulling back, we're pulling back. We just want to say this once so that the wait sand can start, that red block that we had before can start appearing. So it's a way to communicate between state machines. And yeah, this is probably the most complicated one.
So in Elm, does it have this concept of emit? Like you send the messages?
No, not the emit.
Okay.
No. So that's the weird part. That's the part I want to get rid of. I don't know how yet. And I'm trying to turn even the collision detection into a state machine, which has a very interesting bug, which I'm working on. Yeah, but this could work, maybe. We'll see. We'll see if this model works. At the moment, like the game works, but with this, but there's one or two things that make me think this might not work, or need something else than emit, or and then we also have the random number generator on line 13. So you pass it in during a net so that you don't have to do IO in this.
There's no IO in here at all.
Yeah.
Great.
So
or monads.
Yeah, no monads.
Even the ID monad is not here.
Yeah. No dependencies.
No dependent types, no.
Yeah, nothing. I might need to add some dependent types. Yeah, but that's a longer story. I think what would be nice is to get to your entity component system.
Okay. Yes. Entity component system framework.
We also get the word factory in there somehow,
factory.
Yeah. And synergy.
Okay. So
entity component systems can be very non-OO and really like reduce layers of abstraction and amount of boilerplate code. So I think factory, I think it could be a different world.
Oh, damn it. I think you're right.
Like there's an ECS talk where they show all the data structures used in Super Mario 64. And it's like 5 lines or something.
That's very nice.
Wow.
Okay, so I made this example to show off some of the
Cool.
show off some of the things. So this is different from the orbital one because I wanted to show off the yeah, some of the other features.
Cool.
So yeah, so we just have some structs here. So how to describe it? So
Well, think about programming, and then think about everything you would never do if you were serious about business programming. Like, just throw encapsulation out of the window. Go like, what would we de-encapsulate everything?
I don't think that's fair. You can definitely do it in a type safe way. And I would describe, there are many different ways of describing it, but I would describe this part using the array of structs versus struct of arrays.
Nice.
This always confuses me though. I think like so it's an array of structs, not a struct of arrays. So
it's a struct of arrays instead of an array of structs. So here, oh, I see. You don't have any struct with multiple arrays in it. But
well, there is in the background. It's all under the hood.
Oh, okay.
So
I see.
So yeah, so you don't see any entities here. They're all hidden away. But you have entities which have these components, which can have a position, a velocity, a config, or circle component. And yeah, so this is some magic metaprogramming that sets all the storage up for different components. And then what I can do is you can create new entities. So if you call this, you get a new entity with these 3 components, and you set what they are. And the
wait.
Yeah, so
a ball has a position, a velocity, and is a circle.
Yes, and it has this circle property or circle component.
Okay.
And the circle component looks like this.
Yeah.
And a square, and what you can do, you can also negate the components, which is actually really helps later on. So I create a square, and I say it has a position, a velocity, and it's not a circle. And so what I can do is I write my render functions like this. And it's the type signature that goes away and finds all the entities that are both a position and a circle. And this one here, when this is called with one of these combinators, it finds all the entities which have a position and are not a circle.
Wow.
And in my updates,
so beautiful. This is so impressive. The amount of boilerplate this is taking care of for you is so high.
And what's really nice about this example, which you couldn't see in the orbital example, was that the update shape, right? It works for anything which has a position and velocity, whether or not it's a circle. Yeah. And so this will just I don't filter by circle on the type level, and it will just apply this to all of the entities. And if I want to remove everything, then I just have a function from position to not position, and that will just remove everything. Yes, so because not negates the store. So what this does is when I call remove all, so I use this component map. So component map is the combinator that looks at the type and says, and what it does on the left hand side, it will say, get me all the entities which have a position. And it updates to this component, not position. And if you update this, it negates. It actually destroys the entity.
Well, just the position, right? Because now you don't render those things because they don't have a position, and render ball and render square don't require a position. Okay.
Exactly. So in the circle storage and the velocity storage, they would still be present, but because the renders only and the updates only work on the filtering like this, then yeah, they won't be found.
Okay, I also have to take
So-
something back here. Like, okay, so on one end, I would never write business logic like this, and on the other end, I've just not used enough SQL to write business logic. Yeah, I just never end up in the team that works with a database. So on purpose, because I don't want to. But this is probably what you do a lot of the time when you're working with a database. And that would be business logic. So yeah, I'm probably wrong.
It's well suited for code that has to do with life cycles of things. So in object-oriented programming, you only get like 1 or 2 life cycle hooks, like create the thing and destroy the thing.
Mm-hmm.
But conceptually, you might have more, especially in something that's event-driven or a game. And I just think game programming might be different than the kind of programming I normally do. So something like, I heard in one game, they wanted to make it so that like the camera could follow a bullet or something like that. And so they just like added the camera component to bullet and then they
Yes.
could have the camera look at it. And
Exactly.
so deciding ad hoc to combine things or uncombine things or stitch things together. Or like they decided that they wanted when you hit a certain light for it to explode or something like that. This is the kind of thing that in normal object-oriented code with like lots of extending things and inheriting things, I wouldn't really want to do it. But I'm also not so sure I would want to do it with algebraic data types either. Like,
yeah, exactly. And then what's nice about this paper, it's type driven. So the types are actually doing it's the type class. It's a mixture of type class resolution and also some like in Haskell they use like these open type families. But yeah, and then you just have to know these 2 combinators. So you have a CMap, component map, which you do stuff like this. So it's where you on the right hand side you don't have any monad, so where you're just updating the position. And if you want to do some action or you want to read like the global store or whatever, then you need to use this CMap M. So yeah, you use this when you're rendering, or there's other cases like new square. The reason it's a monad on the return type is because you need to look up, well, in this case, you look up, I wanted to show off that you can use this global entity.
Yeah.
To just put some config somewhere.
There's also a set tick.
Yeah, so this is annoying. I need another name for set.
Okay.
Because it gets confused.
Oh my, what is going on here?
Yeah. So this is the
Can we go back to generating the C code file and just like
yeah, I need another name for set prime, but it doesn't
perfect.
conflict, and also modified prime. For some reason it gets confused, and it's also misspelled.
Wow.
Yeah, so the issue with the Lean code is that there's no, or at least I don't know if there's any concept of these open type families. So if you're interested in looking at this, I can try to explain some of it. Yeah. So what you need to do when you define your component is that you need to define a storage for your component, and you need to constrain the fact that the elements of the storage need to be equal to the component type. So what you're doing, this is kind of the trick, how you can hide away the thing that you're storing, the entities that you're storing.
Okay.
So, and the way you do it in Lean is with actual like equality type. And in Haskell, you do this there's a special way of doing this in Haskell with the tilde. So you have like a type equality, but in Lean, we can just use a normal equality type.
Yeah.
But the problem is that these you need to separately define storage for a particular component, and the storage is the elements in the storage. So they can't be defined at this point because the component will use storage. Like let's look at a concrete one.
Yeah, please.
Yeah, sorry.
No.
So yeah, so here's map storage, right? So this is the one you usually use. So it's just a hash map of entity to C, and the C would be the component that you're storing.
Yeah.
Yeah. But you need to be able to define like for this storage, then the element of the storage is C. In order for that, but the number of the storage, the different storage types are open, right? You don't define them up front.
Yeah.
And so you can have these this map storage is not mentioned anywhere in the components because the components is general thing, and it can have different storage here. So so you have to do this. You have to do this horrible thing. And then there's this this trick that I got from Lake actually uses this somewhere.
Okay.
So it's so yeah, I mean the point, but the main point of this is how you define like this families, these open type families. So you can see, yeah, so we have two of them, a way of a function from a type to its storage type, and a function from a storage type to the elements that it stores.
Okay.
And then the component has those two things. So it has like, well, it has a storage, but you can't use any storage. You need to use a storage which stores the component, and that's what this does.
Oh, what is the axiom that you needed to tie this stuff together? I saw axiom and I got very curious.
Yes, exactly. So this is very weird. So this is a trick. So it says that I have this. You basically need to give this equality a name, and so yeah, the type of the storage is C, and so you write it like this, and then the so what you want to do is, what you ideally want to do is you just want to say, I want to define LM_fam of map storage of C is C. That's what I want to do. But I can't do that even as a type a function at the type level, because I don't know what all the storages are to start with. So it's not a closed type family. So I need to declare the function, then I need to declare all the clauses when I define the storage.
So why again do we want different storages? I forgot.
Okay, so there are multiple. Maybe you don't. Maybe you could just get away with using this. But there's global storage, and this is what you use to store the entities. So the entities are components themselves. So if you ever want to work with a particular entity, say you want to you want to actually get hold of the entities which satisfy the constraints, you just add the entity as one of the arguments in the tuple for the CMap combinator, and you actually get the entity. So we have this one here, and then the one that you really want is the not store. So yes, and the other one you want is you really need this because the other one you really want is the not store, and you also want the product store. So if you have two stores, you want the product to be a store as well,
Yes.
and so on. So that's where it gets
Okay.
that's where it gets interesting. So
Okay.
where's all that?
But so this
where it all-
axiom, right?
Yes. So what I'm saying is that I'm just declaring that if I think of LMFam as a like type family in Haskell, so or as a function. So I'm saying that if I call LMFam, so the family of the elements on this, then it's equal to C. So that's
Okay.
like making a definition. So
Okay.
it's like an axiom, but I'm making a definition.
What if a storage just needs to implement an LMFam function, and that LM function needs to show this axiom?
Yeah, so I tried that initially, and you get into a big mess with type inference when you try to define it for the product types. You really need the type family.
Okay.
Because otherwise you could simplify the Haskell implementation as well. But I did try it with this approach first, and it didn't work, and it was so annoying because like the compiler was telling me that like you need an instance of this LMFam type class, and like I've given you one, but it couldn't unify it because it couldn't call the type family. So you actually need this. As far as I know, you need to do it this way. And so this is just like this is a way of defining what LMFam is on map storage.
Yeah.
And then you make that accessible to the type type class inference thingy by doing this. So this is the LMFam is the function from storage to element.
Yeah.
And the family def is the way that you expose that to the type inference mechanism. So that's why it's weird. It's like you've got an axiom, but you're doing like you compute stuff. But this is a weird way of defining a function that allows you to define functions at, you don't do it. You don't have to define the function all at once. You can do it at different times. Yeah.
Very interesting.
And if you were to define it wrong, would it blow up at runtime?
Well, no, but if you define it wrong, then you wouldn't be able to define the component. So if I said this was like nat, then it wouldn't compile. I mean, okay, so I would say nat here. That part would compile. But well, there's loads of stuff that wouldn't compile. But you could maybe fix all that stuff. But when you came back to the component, I would say my component of C has to have a storage. And that storage has to have elements T, and T has to be equal to C. And so you wouldn't have a proof of this, and so you wouldn't be able to use it in all the places that expect this proof. And so in Haskell this is done like I was going to say ad hoc, but I can't say ad hoc when you're here, Max. So I need to avoid this word. What I mean is it has another way of doing it, which is like messy because you have like type level equality and term level equality, but here we have term level equality, and so you actually need to use this proof to make everything work. Where was
I wasn't criticizing. I thought it was just really cool. Like you're really bumping up against the edges of the system here.
So let me just show you one more thing, which is like where the proofs actually get used. Because in Haskell, the type family stuff, the compiler hides all that away from you, which is where is that stuff then? Yeah, and the thing is, I'm sure I can improve some of this stuff. So
I don't know.
Yeah, here's the not store. Yeah, so for example here so I have a component and it has some storage, right? And then I want the not component to have the not store, and it should have the not elements. And so I use congr arg. So I take this constraint is the proof that C is equal to ES. And what I need is that not C is equal to not ES. And so I use Congra arg for that.
Nice.
So, but what I wanted to show you was the product type. Where did I get rid of that? No. Where I'm running out of files.
Where's the logic of negation actually implemented?
Ah, yeah.
Like
It's a
if I
very good
want
point.
not a circle.
Ah, yeah. Not a
No?
circle. So yeah, so you can't iterate over all the not things. So you don't. There's a thing, but
Because
you
it's
can.
cofinite.
Yeah.
Oh
So
wait,
that's
no.
not implemented. But what you can say is, you can say I can say exists. So if I get something out of a not store, it's just equal to like I don't have it. But I can say that I can look it up in the original store and then just negate it here.
Oh
So
my God.
what it means is that you can't use not. You can only use not in the bouncing balls. Where are we? Yes. So I can only use not as a filter. So I can't have a CMap with just not circle. Nice. I can't get you all of the entities which are not circles, because this is like we'll be here for some time. So you can only use it as a filter because if you look at the instance, if you look at how the product is defined, then you only need to be able to get all the elements of the first thing, and all of the others you just need the exists type class because you're just filtering. I want to show you that, but I've run out of files. Where is that? It's not in ELAB. It's not in entity counter. Where is it?
This not thing is really clever and seems really useful. Like in the entity component system I implemented, you had to literally write filter in order to filter things.
Right. Yeah. So here's the filtering. So let me get rid of this because it's too wide. So yeah. So if I my storage quad LM. Yeah. So I need to use the where is it? Yeah. So here we go. So I have two storage here. And then I get all of the entities in the first, and then I just filter by all the others. Yeah. Nice. Well, but by all the others, I mean the other one here. But this, if I have a product, the type class inference will just deal with this for me. So yeah. Wow. So yeah. So and this is an important point when you're using this. You should have something with the smallest number of entities in the first component of your product. Yeah. But so for example, there's one here which is so I have components CA and CB. Then this here I have a component A cross B, and it has storage. It has storage SA cross SB, and the elements of the storage are EA cross EB, and I have to use the proof. I have to prove that here. And I want to show you where the proof gets used. There's Congra arg.
In the Haskell implementation, do they use proofs, or is this something that you've added?
No, because the Haskell has type level equality, and so that's what they can use for that. And the type level equality is kind of, it's all inferred, and so you don't have to manipulate the proofs directly. Yes, I think there's like sim. I use sim somewhere. Yeah, here we go. So here is the here's the C map. So the component maps a function over all entities with the CX component and writes the CY component. So I need to use the proof here, and this MP is something that's, yes, proof of type equality. Because what I'll end up with like one of these weirdo types, and I have a proof that so I'll end up with like the components storage is element, and I know that's equal to the component. So I need to use this type equality thingy to actually, when I have a function of components, I need to convert it from a function of like the component storage's element into the component. So I need to do this. And so this max is here. If you defined your storage elements wrong, this proof wouldn't work. Yeah, things like this. Yeah.
It's delightful.
So this is one of those things I just because the end result's so nice, I just wanted to get this to work.
So Walter, do you still not like entity component systems? I think that they arguably can be made type safe.
I don't say I didn't like them. I said this is just
it's not how you normally do things. Yes.
Yeah, this is not how I would program things for work. This is all I'm saying.
Unless you were writing a game engine for work, maybe.
But I wouldn't do that because you're underpaid usually. So
there are other reasons why you wouldn't do that. They're unrelated to the type safety.
Yeah, no, I don't work for not enough. No. And this is amazing. Like I like on two levels, like I'm very intimidated by all the types here. And on the
you never have to see them.
Yeah. On the usage side, I'm impressed with how user-friendly it is. For a game.
So so this does all of the nonsense of like, well, I need an I need a storage for this. It creates my storage, and then I need this axiom, and the meta programming is pretty good. So this anti-quotation is much better than if you were to write this in template Haskell. Because template Haskell, you actually need to use the template Haskell language. You don't have the anti-quotation. Yeah. I just don't know how to make fresh names, which is like, after all this, I was like trying to write the meta programming and I can't, I want like,
I haven't heard the term anti-quotation before. I wonder why they don't call it tation.
Yeah, I think anti-quotation is the word.
Oh no, I wasn't saying you're wrong. I was just saying there's this opportunity for
confusion.
No, for creativity. Like one of those terrible category theory jokes where you add or remove a co and it's supposed to be funny.
Yeah.
I've also heard them called Quine quotes, because Quine invented them.
Ah, interesting. Yeah, so I'd really like to know how to make fresh names that wasn't like this. So, I don't know.
This looks about.
I just want to make it. There should be a function, right? Give me a fresh name, like a unique name for in the scope of my elaboration. But I couldn't find one that worked. Like it would give me a fresh name in some part of it, like a fresh name in this elaboration. But if I called this somewhere else, it would like reset all the names. I don't know.
I'm checking whether I have something for this, but I don't think so.
Yeah, I thought I did. I looked. I couldn't find. I'm sure that we did that when we did in the proofs. Like we needed fresh names. But the problem I was having was like.
Okay, I have something. Yeah.
Okay.
So, you need the. Yeah, it uses local context. So I am I'm not sure that would work for you.
Yeah, because what I want, yeah, exactly. I think that's what I'm coming up against, because what I want to do is, like, I want to create a structure with like some names, and then I want to use those names in the instance that of that thing I've defined. So the problem I was having is that I'd create the fresh names, say, in this context.
Yeah.
And then if I use them here, the IDs all get reset. And so, yeah.
Yeah. No, my fresh only works in a local context. So I don't think.
So I need maybe a way of like making an overarching context, like a macro context in somewhere. But at that point, I just wanted to get it to work. So it's like, well,
yeah,
just give me a fresh ID and I'm going to make it into a string so you can't mess with it.
Yeah.
Yeah.
Yes. It looks okay.
I mean, it's fine. It works even like in yeah, you can put it in a namespace and it still works and so on. So
I've seen worse. I think it's fine.
I think the C code generation is worse.
Yeah,
we've seen worse in the last hour. Yes.
Yes, exactly.
Okay, well, I mean that's that. So that's not really writing a game. That's writing something to write a game.
Yeah.
So we can. Yeah, and this is not really a game. So I haven't written a game yet. So I need to write a game.
Well, you did orbital mechanics, right?
Yeah.
Yeah, the thing is that a game? I don't know whether that counts or not. Like, I need to add some like Jeopardy or something. It's too serene, right? I can.
Not all games are violent. Like some games are just about being serene. Like there's like this diver game, and we just dive around.
Oh yeah, I played that. Yeah, I like that. What I thought about this was maybe you could do like rendezvous with different blobs, and you try and do it in like the least amount of fuel or something like that.
Or just like, what if you also have some gravity on you and you influence the other balls?
Yes. Yeah, that would be.
That's enough.
Yeah.
What, solving the three-body problem? Yeah.
No, this doesn't solve any problem. This doesn't even solve the two-body problem. It just like it's doing like dumb integration approximation. So yeah. See, it doesn't require anything.
I think I like it's pretty like I can stare at it for quite a while. Like it's
I was playing up until today. I was constrained because I had a memory leak, and so Max, I was playing it for a while, and then it started stuttering, like the frame rate dropped, and it was because it was consuming 100 gigabytes of memory.
Yeah.
But I fixed that today, so I can now play it forever. So
nice. Show us a bit how this works, because now you're.
If you can play it forever, how does it terminate?
This is a good point. It doesn't have to for some reason, and I don't need to say unsafe anywhere. So it.
I think if you're in IO, right? I think it just.
Yeah, I'm in IO, so everything, all bets are off.
It's fine. Like.
Yeah. Yeah. So this one. Oh yeah. Let's try the stuff. Why did I do this? I'll put this in a separate thing, but you can't see it now. So yeah. So it's this. I think a lot like in the Haskell library, they have a separate library just for physics, and I can imagine that you would do that because a lot of the time you have like a position of velocity, you want some physicsy thing going on.
Yeah.
And so so then we have this orbit path, which is this thing that drags along with you, and then this is not good, but selectable is like active or something. That's what picks the green one. Maybe I could use a component for that, like active or something. rather than the bool. So I think that's like probably not idiomatic. So yeah, it's the same thing. So I say like, well, I make an orbiting body. Well, so I've got two types of things, right? I've got orbiting and non-orbiting, and I distinguish between them by giving the non-orbiting body, the fixed thing, the red thing in the middle, doesn't have a velocity. So that's how I distinguish between them. So yeah, I can make orbiting bodies and I make static bodies. Static bodies just have a position and they don't have a velocity. And then, yeah, I update orbiting body. Yeah, I can change the velocity. Yeah, so this is, so you shouldn't use a bool here. I think it should be like active or player or something. And you say not player instead of selectable and check the Boolean flag.
That is kind of okay, isn't it?
Yeah, and yeah, I'm not sure. And so yeah, your update is just a collection of these D maps so there's no action here, and then yeah, rendering.
Wow.
That's it.
So clean.
Yeah, it's beautiful.
So yeah, this is the where is it? Oh yeah, so this is the orbital mechanics part. So it's just doing the dumb thing. And this is the you can increase this to increase the gravity. So make this, or make your gravity repellent or something like that. I don't know whether this will.
Oh, we need a button for this.
Yeah, exactly. We need to toggle it. No, it doesn't really change it. Okay, well, yeah, they're just like they just go up to infinity. I think the problem is that yeah, other things like when you hit this, you should explode or something. If you get too close to zero, then floating point errors just dominate, and then you just go to infinity. Yeah.
Interesting.
Anyways, those are all the things that we have, all the ways that we have to make games. So we just need to make games.
Yeah. Wow. So, well, we can play a bit with Orbital.
Yeah.
And change it up a bit if you want.
Yeah. Oops. Yeah, so I did this thing now, so I can say. Yeah. And just run this. Whoa. Okay.
Oh. This is fun, Ray. Whoa.
Yeah, we'll go up to infinity. So.
Okay. What can we change? How about, do you think you can have, how hard would it be to add gravity to the player?
Yeah. Just the player. So this wouldn't be static anymore. Everything would have a velocity. Yeah.
No, so the rate thing can stay static.
Yeah. Okay. So we need to okay. Yeah, so we have to give. Yeah, let's try that. So what we would do is each blue thing and the green thing would have its own mass, and it would be some fraction. So basically, this number here -1 is like g times m, where m is the mass of the red thing, and so everything's normalized to 1, and so we just need to do.
So does this make an assumption that there's just one static body? Does this function do that?
No, it does. Yeah. So update orbiting body. It assumes that there's only one gravitational influence, which is at the center of the
Okay.
screen.
Oh, okay.
And
Okay, so that would be pretty hard to add more.
Well, you would. I'm not sure actually. Not sure.
Or what about we start with just adding another static body? It's just
Yeah. That's
like
and then that's one thing I wanted to do was, the in the paper they call some stuff kinetic. So maybe you would say like this product is like
yeah.
orbiting,
Mm-hmm.
and this product is like, which is the where's the other one? Oh, sorry, this one is not orbiting, something like
Yeah.
that. That would be just this. Yes, this one. Yeah.
Cool.
Probably. No. Oh, okay. Drat. Why can't it figure that out? Okay, so it
Is it
it doesn't know that this okay.
it can't do alias unfolding?
Yeah,
Is
no,
that
we can do no, because that's not alias. We can use abred. I think that
okay?
will work. Yeah, there we go. Yeah, otherwise you'd have to define instances for all of those nonsense things.
Okay.
How many more of these have we got?
This is the first time where I've actually seen the difference between diff and abref mean something. Like change whether something works or not. So yeah, it was good. Thanks.
Right, yeah, I needed to I don't think I use this anymore, but I needed to. This was one of the things I was trying to do when I was trying to get the thing that you suggested to work. Was like, anyway. So I can position, velocity, orbit path, position, velocity. So orbiting doesn't have selectable.
Yeah, it
Oh, it
doesn't,
does have selectable.
but it doesn't have to have it.
No, it doesn't. You can put it in.
Yeah.
This to be orbiting. Will this work? No. Oh, because it's in the different precedence, isn't it?
Yeah.
That.
Okay, but
That's annoying.
We don't need this abbreviation, right?
No, we need to figure this out though at some point, because we need to give names to stuff. Maybe
off stream we can figure
off
that
stream. Right. So what we want is another static body.
Yeah.
Sometimes stuff just works and you don't. Oh, maybe it will just work.
I thought this update orbiting body had a assumption.
Oh, it does. Yeah, you're right. Yeah, because we have to figure out.
So I'm thinking by adding another static body, we can maybe remove the assumption.
Yes. Yeah, so we need to.
So currently we're querying just for the orbiting stuff, right?
Yes.
But really we need to query for both something that is orbiting and all the static stuff.
Yes. So,
right?
How do you do that? Do you do like a sub? So I can say like everything that has a position, I can query for.
Then
inside that, I need to do another one of these, which queries for. Yeah. What? Yeah. Now we have to actually think differently than we usually would. So if I get the if I get everything that has a position, then I need to figure out whether it has a velocity.
Yes.
If it has a velocity, then it's orbiting, it's not static.
So we might need some C maps inside this function.
Yes. So there are other...
Or filters as well, actually. Maybe filters.
So, yes.
It's a bit
Let's go to ECS system. So these are the things that we have. So you can say whether an entity has a component. But for this, you need the actual entity. So you generally, I think you want to maybe avoid.
Yeah.
And we can't actually do that at the moment because there's a bug with the way that the entities that come out of this. So everything's like off by one, and so we can't do that. So that's going to force us to try something else. So maybe we have to do the CMap inside. Let's try that. I just
like the idea of this ECS is that it should be easy for things to interact, right?
Yes.
And I felt I understood this, but now I'm struggling.
Yeah.
What are we trying to do again?
Trying to add another static body. And to do that, we need to change the assumption in update orbiting body that, well, it has this assumption that there is one static body in the center. So
yeah. But the thing is that we can use system.
Yeah.
We can use system because system. Sorry. We go back to system. We can use CMapM. So CMapM allows us to update. So CMapM has two uses. The M here allows us to use IO, but it also allows us to do like it allows us to do updates with other CMaps. So it has like two purposes.
Okay.
So I don't think I've ever demonstrated the other purpose, which I think we do here. So because what this update orbiting body, it's going to update it's only going to update the orbiting stuff.
Yes.
So let's, yeah. So it's going to, I think the type signature is going to look like this, and then system world unit, because we're going to do a CMap M under here.
Okay.
So that's the same thing here. So we've got all of the
so now it's like a for each, right? So for each of the orbitals.
Yes.
So for each of them, we need to go find all the static bodies. Because all the static bodies are going to have a gravitational pull on us, right?
Yes.
Isn't that the same thing as the product of the orbiting bodies and static bodies?
Yeah.
Is it? Because it's you filter by the. So yeah, if I do this, and then the position, not velocity. Doesn't that mean get me all the things that have this and this? So it's just going to be empty.
Yeah.
Or is
that's how I understand it.
Yeah, because you're filtering. You get all of these, and then you filter by these.
Yeah.
Oh, never mind. I see.
Yeah.
I see. It doesn't mean
it
means intersect.
But we want. Yeah, we want an and. Yeah. But the thing is, we don't want to do this for every. We don't want to find all of the static bodies.
I think we do.
No, not for each orbiting body though.
I think we do.
Ah, okay.
That's what I'm thinking.
Okay.
Like, because
Right.
each orbiting thing is influenced by all static bodies. Right? It's not just the closest one. So it is technically it's a for loop in a for loop. Like,
yes.
And we already have the for each down here. We've got an each going, but now we need an all. So we need to find all the.
Okay. But the static body is not going to change.
No.
Static body is not good. So maybe we should get all of the static ones first, and then
Yes.
do that in the out. No. Ah, okay. So, well, let's try this. Let's try this first. So this one. Position, velocity. Then I can do a C map here. And do C map M. So let me just do, I don't know what to call it, update with static or something. Oh, right. And then my update with static, this will find all of the, yeah. So this will, well, okay. So he's going to have all of this stuff passed into it. I don't know when to.
Yeah, you don't want to update the static items.
No, update with static. So yeah, let me just write the type signature.
Okay.
I mean, the type signature is going to be this, okay?
Yeah.
Because you want to update these guys.
Okay. Yeah.
I'm not sure. Let me just write. So you pass this in. No.
Or okay. Here's
And then you
I don't know if this is possible, but can you have two separate parameters that are like one parameter is position, velocity, orbit path, and the other parameter.
Yeah, that's exactly I think what we have to do.
Yeah.
This is like the outer stuff.
Mm-hmm.
Again, I'm not sure what the name is, but then what we want here is we want something from the position cross not velocity to this one.
Yeah.
I think that's right.
Yeah.
And then drat.
Maybe that function.
Oh, sorry, yeah, because I haven't passed it the. Yeah, so this is also. It'll figure it out once. Because that will be okay. Because this gets passed in, then the outer C map gets this function, and then we just want to pass that. We just want to pass that into this. What have we done? I think. All right.
Yeah, I think you just need the top function.
Yeah, exactly. Yeah, we're getting there. So because this is now just get passed in the outer.
Yeah.
So I just want to see if it type checks. Yeah. But that should be okay.
Does that need to be in parens or just? It needs a float.
Expected type DT outer system world units. No, it can't figure this out. This should be okay. I mean, I can give it, I can pass it the, I just need to. That's okay. Because I'm passing this position velocity orbital path. I just need to pass like explicitly pass something here, like the CX, and then find out what's happened.
Okay.
Like passing the CX, because the CX should be position cross not velocity. Sorry. This, yeah. What should the type be? This type is the wrong type. Yeah, maybe it's not a CMAP M then. Maybe it's just a CMAP. Would that be right?
Yeah.
Because that's the thing. There's no monad here. It's just.
Yeah.
Is that it? Yeah, I guess it is. Because what you're saying here is that you're saying, right, that you have to CMAP M this one, because it's a position velocity orbit path to system world unit.
Yeah.
Oh well, okay. No, but this surely doesn't type check.
Does it need to be system world unit?
No, because it does. Yeah, it does. Yeah.
Oh, okay.
Okay. Yeah, because it's updating the. It does. Yes. The thing I forgot was that it's the function just updates the components,
Mm-hmm.
and it's the CMAP M allows you to do stuff in the monad in the update. That's the difference between map-M and CMAP. Okay, so that. So did I need this? Did I need this function?
I think. Well.
Let's see.
Because you need to go find all the static stuff, right? So.
Yeah. I mean, could I inline this? Anyway, what I've done is usually I've split these out. So I have functions that return system world units, and I have functions which are like pure, and I just have them as separate things. And and then what we do, you just undo them with using this. I think this is works the best when you destructure.
Yeah.
Because you have to unwrap the new type. Yeah.
Sorry, what are the angle brackets doing? Are those tuples?
Those are like, they infer the constructor. So you're just destructing and you're just like, I don't care what I'm destructing. This thing only has one constructor and one these. So you're just like implicit pattern matching. I don't know if that's the right, but.
Oh.
I think maybe the outer one also needs to be.
Oh, sorry. There's only two components here.
Oh, okay.
Yeah, not velocity and position and not velocity. So I can just do that. So, yeah. So here I'm using the other style here, which is you can use the name of the constructor, position.mk. But as usual, you get these fancy things and you start using them, and then they become second nature, and then it makes it impossible for other people to read. It's how this kind of thing works.
That's okay. I haven't written much Lean, so I'm sure I'd get used to it.
Yeah, it's nice when you write vectors because you can write them like this. They look like vectors. Yeah.
Yeah, that's the only cool use case. Otherwise, it's. But it's like you don't want to write it, but you do. Like.
It's so much fun to use non-ASCII. Yeah.
Oh. Line 35 just has a little typo on it, but yeah. I think I even read like there's a way to not do the circle brackets as well.
Yeah. So in Agda, you wouldn't need them because the comma is just a constructor.
Yeah.
Like an infix constructor. So how can I?
You can put the angle brackets there instead of.
Oh, right? Yeah. And then without the comma is also the separator. So it's both the constructor of pair and the separator in there. Oh,
So
I'm not sure I like that.
no, no.
I should use
like-
position.mk.
Oh,
No,
okay.
it's okay. It was an idle question. Don't let
No,
me.
no. I just think I don't know what I prefer now.
Hmm. But there's
I like the brackets. You've got the type signature right there. It's pretty clear.
yeah, but there's some way you can get like more deeply nested destruction without having all the angle brackets there. So, but I can't remember how. But
I'd like to destructure the type signature, but I can't. I think. Yeah, I mean you can't. I mean, okay, that's probably fair enough, but
yeah,
it'd be nice to be able to do that.
Do you miss writing the function name over and over and over again, like in Haskell?
We don't have to do that now.
yeah. Don't miss
We
that.
have \case, lambda case extension.
Oh,
yeah.
Yeah, but that's
It's an extension. Like,
no, it definitely.
Well, you don't want to see how many
enables random case.
extensions this entity component system has in Haskell. Has them all enabled. Yeah.
yeah, no.
Well,
Okay.
it doesn't have undecidable instances or no
Oh.
incoherent instances. That's the best one. Incoherent instances.
Well, you have axioms, is what they're gonna say. Yeah,
It's not an extension though.
No, I prefer it, but okay. Well, let's try to update this. I want to see.
Yeah, I think this is going to be difficult because we have to do vector calculus now.
Yeah.
Because everything is relation to the.
But the good thing is, we don't have to get it right.
Oh, you're right. Yes, indeed.
We don't have to do this perfectly. We can just do something.
I want to do. I want to destructure that.
Well, it will actually be good, right? To just still include the assumption, right? And just replace the one function with the other and just see if it still works.
But we can't. Well, update opening body. We can just wherever it's called.
Yeah.
It just needs to be a CMAP M, I think, instead of a CMAP now.
Yeah. So we just see if it still works before.
Oh yeah. So without doing anything here.
No. Well, doing it, but with all the same assumptions. Like we don't update our. We don't do any math. What is it?
Okay. Yeah.
Oh no, arithmetic. Is that the
vector calculus?
Physics.
Physics. That's it.
Okay.
Where's the DT being used? DT is being used here. Yes, it's not here, is it?
Yeah, we're past that.
Yeah.
And your CMAP.
DT. FT.
Cool.
Okay. So we're claiming this should work still.
Yeah.
So I should be deleting that. Oh, this doesn't use P. Oh, we shouldn't use P because that's the.
Yeah, it's fine.
That's the location of the static body. Yes.
Yeah, and we're still operating under the assumption, so
yes,
that's fine. I think you have a tick, which you need to remove.
Yeah, I need to remove that tick. I need to update the call. This needs to be a CMAP. Oops. One of those. No, the difference is not difficult. It's just one of them you're allowed to.
I think I just figured out how I'm going to use this. Just add underscore until it works. Like...
You've got three things you can use: CMAP, which is pure, and then you have two impure ones, and then yeah. Right. Let's see what breaks now.
Yeah, this is the unused variable. Okay.
But our universe is somewhat devoid of math.
Okay, so something didn't work. So this
Something
was a
didn't
good
work.
taste.
Nice test, Walter.
Okay, so what we're doing here, we're saying that we're getting all things which have position velocity in orbit path. Hold on a minute, we made a static body. We didn't render it. Did I mess the static body up? Why didn't we render it? We should have rendered it at least. Render
Good
static
point.
body. Or did we delete it somehow?
I don't think so.
I'm gonna remove this.
What does Git say?
Yeah.
Oh yeah.
Huh.
No. This should. I'm just gonna comment this out and see whether we get a static body. It should
Okay.
render it. It should render it at least.
Yeah.
Okay.
Okay.
Why did that affect? So we must have somehow deleted it. I think
maybe because we didn't return it again from update with static.
yeah, we need to. Yeah, this is a problem because what we're doing, what this is saying is, yeah. Look, what this is saying is, give me all the static bodies, and then I make it non-static by giving it a velocity. This is update. This doesn't just get all of the static bodies. It gives them an orbit path and a velocity. This isn't what we want. We want the outer thing. We want this to, and this should be some intermediate thing. I think what you maybe have to do here is get all the entities, which, because in here you can yeah, because we don't want to update anything here. So we shouldn't be using CMap with this at all. I think we have to use like members directly or something like that. So we can say like, yeah, I don't know how you do this. Yeah, because if we call CMap, we have to, it will update whatever we give it. So
yeah.
we have to, I think we have to use members to get all the members. So maybe I think I am missing some stuff here. Like I haven't implemented some things.
I think in the paper they also said sometimes you have to use members directly. And
yeah. So we could do that. The problem is I think there's a bug which might have. But how would we use this?
You just want to read
the
the static body, right? You don't want to write to it.
Exactly. So that's why we shouldn't use the CMap. I think that's where we're going wrong right now. So we just want to read. But how do I do that?
Can you pass the information in?
Yeah, but we have to say like, give me all of the members of that component. I'm just trying to figure out. Yeah, I mean, maybe it just works. So where can I try it? So this is definitely wrong. And the original signature, I think, is still. Yeah, I just want to see whether we can. I'll just use I mean, it won't be the right thing, but I just want to see if we can get all of the static things.
Yeah.
In the monad. So how would I call?
Just for curiosity, members. If you did want to mutate it, like with a no-op mutation, could you grab it and return it?
Yeah. Yeah, you could.
But the type signature, are you only allowed to talk about one thing then? Like you can't.
Yeah. So this, when you do this, you're saying, give me these things, and they're updated to these things. If I call it with CMap.
Yeah, so you can't talk about multiple things at the same time.
No. No, you have to use the what CMap is doing under the hood, which is you have to get all the all the members of the. I wonder if you should. There
Can you
should be like
return
a system.
extra data? Like, could you go read information about all the static bodies, like just map over them and then pass it in to the other function?
Well, that's what he's kind of trying to do with.
Yeah,
Oh,
yeah.
okay. Yeah,
I think that because what we don't want to do at this point, we only want to get the data. If we use these functions, they get and set the data. So I think maybe there's already a function for this, but because what we want to do is we want to get like.
I think it's exactly like this explicit members that you want to do.
Right. It's just the explicit members is on the storage, it's not on the component. So maybe we need to like, what would the signature be of like members? It would return like an array of what? Yeah, we only want the data, don't we? We just want an array of the components, basically.
Yeah.
So maybe we can just write that then.
Cool.
Why haven't I already got that?
What does get do?
Yeah, so get gets by entity.
Okay.
So this is the thing where if you know the entity, then you can get stuff. Like that's what I'm using for global. So there's like there's a global which is just a global is just 0, and you start counting from 1. Yeah.
Okay.
So I think we need members, which just gives us all of the components. So I need probably we need these.
Yeah.
I need you. What else do I need? I need a component.
Yeah.
I need a thing that says my world has that component with that storage, which is the thing that's auto-generated. And then I need members. And then
we also need get.
I think what does members have? Yeah, they just it's array of entity. I need get. Yes, you're right.
That's
get as well.
expl get, that one, yeah.
Yes, expl get. Then I return system w array cx. Cool. I need to get my store. Get my members. I need to make my array. And for all the entities, I just push.
Yeah.
Push. Oh, res.push.
Yeah.
And can I do that?
I think the raise colon equals raise.push.
Oh yeah, you're right. I always forget that.
Yeah.
Oh. Yeah, res.push, and then this thing. Is that gonna work? Ooh. Mismatch. What?
Well, I think you still need to return, right? Maybe just do the.
But what's SL? Oh yeah, I need to return res. Yeah. Ooh.
TX?
Oh. I need to use the proof now of the.
Okay.
Okay, so we need to make the TX. We know that TX is equal to CX. So we just need to we need to prove that now. So if I get like comp x dot, comp x dot constraint. Yeah, so I have TX is equal to CX. So how do I do that now? I've got an array of TX, and I have this, and I want an array of CX.
by a rewrite? Can we just
rewrite? Clever enough for this? Give it a name in a minute. So I want an array of CX, right? By rewrite. Yeah. Okay, we do get to prove something now.
Yeah.
Oh, but I need to return it. I need to return this, right? Yeah, that's why I'm getting that type error.
Okay.
So let me just check that it type checks.
Yeah.
Okay, good. So we just need this proof. We just need to prove this.
Cool. That should be.
Rats. Now backwards PF.
Oh. Oh, what? Oh, okay. And then just exact arrays.
No, we need a CX. No. We need
It's
Why is
okay.
it saying we want a TX? Ah, no, it's yeah, okay.
It's fine.
Exact what? Sorry.
Or assumption.
All right. Works. We did a proof. Okay. You see that in Haskell, the type checker would, or whatever system would figure that out for you. So what else? What I can say? Comp x dot constraint.
Yeah.
Did I just do it the wrong way? Why didn't I end up with a CX? I wanted to see a CX here.
Okay,
could I have done that?
Yeah, in raise.
Oh.
Or at raise? At.
Yeah, one of those, isn't it? Great. Yeah. I prefer that because then it looks like I'm gone the right way, not gone down the wrong way.
I think you can also do cases on complex.constraint.
Okay, let's try that.
Not on, just cases complex.constraint.
Oh, right.
I think it's that.
Yeah, on was in the meta language there.
Yeah, there we go. And then
what cases have I got
sorry,
here?
yes. And then just assumption is fine. Yeah.
Nice.
Yeah, I learned this while trying to redo some Agda and Lean. And we didn't have equality. We had type, like the other equality, the type equality that we made up ourselves. And so you can't use rewrite. So it's just like, what a pain.
Do I need to bind this, or can I just say bye and we'll figure it out?
What do you mean?
Oh no, because can I just say return bye? Is this like an expression?
Oh, interesting. Oh,
yeah, let's try it.
I mean, why not try it?
Yeah, I want to say like return, and then I want to do like, well, oops, not that one.
Oh,
wow. No, wait.
Oh,
We got it.
So close.
You couldn't figure this out.
Yeah.
What? But we had it. Oh, maybe it didn't type check before.
Oh?
But you know it's an array of CX. Why is this is the kind of why you talk? Why is it failing here? Let me try that again. Maybe it's because I had that there. What are you complaining about? Fail to synthesize what? You're not saying that.
Well,
yeah.
If the proof rewrites.
Well, that's just the Emacs thing not showing you, right? Sorry.
Does it think you're doing has.getStore on the wrong type because you've rewritten the type with the equality?
Good question. Fail to synthesize has expl members SX. Yes, it is. That's exactly right. Because that should be what you need is expl members SXTX. But because of this, how can that affect the Because in this whole thing, TX has been rewritten to CX.
Yeah, so when you do this kind of thing in a camel, it just keeps both of the equalities around. It's fine. It's not like you lose one because you've added one.
That's very annoying. So I have to use it
But
to give all the proof here.
how does the let fix it though? That's the really
Just let it be.
Yes. This would be so nice though, right? It's like, oh, I've got an expression here and
Sorry, just let it by.
let it by.
Let it by. Let it by. Let it by.
Yeah, because if I look at the whatever.
So is the type annotation doing work? Is there a way of annotating on an expression rather than a let binding? Because then you could perhaps return by.
Oh.
You mean
Like if you take the entire by
yes.
and you put it in parentheses and then give it a type description, are you allowed to do that? Like
No. Single
Oh,
quote
sorry.
as well. And I would put it on the outside of the brain, but what?
Oh, because this is already a paren.
Yeah, okay.
Okay. And then where do you want me to put the types? So what that should be?
I wanted to put it outside the brain, but like
Oh, like this?
yeah.
I don't think that's valid because
two sets of parens.
Yeah.
yeah, okay, good. Yeah, I see what. Yeah,
Compromise.
I agree with that. Yeah, it's not going to work without this set of parens. Well,
Okay.
what should the type be?
What do we want to return?
CX.
No, just CX.
Yeah, what am I doing? I'm returning a proof.
Yeah, this is the array of CX.
But that's not the type of by thingy, is it?
This shouldn't work.
There you go.
Suspicious. What? Why is the type of by array CX? I thought this was a proof.
It is.
You're applying the proof, which
Oh yeah. Which is better, the binding or this?
oh, this is horrible.
Yeah, definitely not this.
But it is cool that you can do it, right?
Yeah, but why doesn't the other thing work? Because this annotation should come from this guy.
Yeah, it feels like it should have been very explicitly inferred.
But then yeah, okay. I don't know. Okay, well, I'm just going to leave it like we don't know whether this does what we want. See, we're getting sidetracked by this is
Can
fun,
you
right?
erase the type annotation array CX and see if it fails to type
Yeah,
check? This will validate my understanding of what let's do. And I'm wrong.
Because I guess it's figured out from this, but why couldn't you figure out the other thing? Oh, look at the proof that you get. Wow.
I mean, I would have expected. I was thinking the type annotation was really doing something.
Yeah, me too. I thought that was the load-bearing thing. No, apparently it is load-bearing when you try to just return the by directly. It's not load-bearing in the let, which is like, this is not how I thought let worked.
Yeah.
Oh, okay.
Okay, good.
Okay, do we want to update the orbital path?
I want to see whether this members thing works.
Okay, what is more fun? You know, seeing the shapes move or this? Apparently,
I like thinking about how let works. I really enjoyed that.
See, we're having
to
fun.
get away from proving stuff. We failed like miserably. We're having too much fun.
Yeah. What were we doing here? Oh yeah, so now we don't do this.
We can go back to the proof. Sorry, I was just kidding. Like, you know, like whatever.
No. I wanted to go here. I wanted to use what we just did.
Oh, okay.
Because cool. I want to see whether it works or not, or it just like crashes or burns when you try to run it.
Yeah.
Right. It's because what we want to do, we want to go back to where we were, but we just do that into. Oh no, we can't quite go back to where we were. Yeah, how are we going to do this?
Now
because we need. Yeah, but we have to be in a system world unit context to do that.
Well, we
Yeah.
are in update orbiting body, right? Isn't that?
Oh, you're right. But I wasn't before, you see, because oh no, because we do the CMAP, right? We do an internal CMAP of this thing.
Mm.
And then we have to pass in all of the static bodies to this.
Yeah.
Yes. So we passed in static and whatever they are. So basically just position at this point.
Yeah.
And why is that?
It just seems to be a colon.
Oh, yeah. Yeah, it turned into a colon. And this is... Oh, no. No, sorry, because I want to do the... I don't want to destruction. Yeah, okay. So
cool.
I write it like this because it's like, well, I'm doing this transformation between these.
Yeah, that works for me.
Why is this?
Now you need
shouldn't work, should it?
Your
I need 3 things here. Oh, because the underscore probably is, yeah.
It's double.
Okay, because that's the problem with that. Because yeah. So if I do it like that, it's going to tell me I'm. Oh no, it doesn't.
Are tuples nested?
Yes.
Yeah.
That's the one that was what I was talking about.
I can't bloody things. Okay. Right. So you don't need to be here, and then we want all the static stuff. So we get static. And this is array of. Right, so I'm going to have to give it all of the stuff. Yeah, and then
it's okay. One step at a time. Let's just get the. So it's just the things with not a velocity and a position, right?
Yes, and it needs to be this way. Yeah, not velocity.
Yeah.
The not has to come second. Yes.
Yeah.
And I bind that. Oops. Nope. Members.
Yeah.
What? Is it just it should just be members.
Yeah.
Woo!
Ooh, that's cool.
Look at that. Oh.
That is pretty cool.
Let's see. Maybe update with static DT. Yeah, so now I guess let's just pass it in. Oh yeah, because this needs. Yeah, I need to like map first or something here.
Okay, but just pause in the array for now.
Oh yeah.
And then let's see. Like, does it work now?
Yeah.
Should.
Okay. Right. So now I should run it, and it should. It should work.
Yeah.
But why is this here? Because yeah. I want it to look. I want it to look right.
Yeah.
Oh yeah.
Using static because we aren't. Oh, what's going on?
You're not in a monad. You're returning a function.
Oh yeah. That's true. But that can't be right. Oh, so it's unhappy about this. Okay, we just stuff this here. No. Wait. Something else is wrong.
You have the left arrow on line 47, right?
Yeah, I think it's what Max says.
What should be here?
Well, isn't it what Max said first? Like you're returning a function.
Oh yeah, you're right. Yeah. So this needs to be. Oh, I can't do that. Yeah. Okay. Yeah. So I can't do that.
It's just easier.
Never mind.
Yeah.
If you wanted to, you could immediately pattern match outer, but I find the way that you have it now easier to read. And then don't you want CMAP instead of CMAP-M?
Yeah.
Yeah, we do. Yeah,
Cool.
thank you. But then we're not using.
Yeah, that's fine. Right? Is it fine?
Yeah, so we don't do this. We don't do this anymore. Yes, because this is doing the update here. This is updating everything with a position velocity and orbit path.
Okay.
But so I don't need to pass it in on the outside.
Okay. Okay.
Yeah,
Cool.
so this is just now. So now the call site will change. Yeah. So I don't do CMAP M. I just do update. Yes.
Okay.
Because this is already.
The fourth configuration. Okay. CMAP, CMAP M, CMAP M underscore, no CMAP.
No CMAP. Well, we're already a system.
The 4 things to try until it works. Okay. Cool.
Right, let's see what happens. So what? I'm curious now.
Be the same. Yay!
Yes.
Beautiful.
Okay.
So I mean, we're at time now.
Yeah.
So I don't know.
Yeah.
What did we achieve?
We made members.
We made members. I'm not sure why. Maybe this is this in the paper? Surely.
I think they
I just yeah.
I think
don't
they
see
did
it.
explicit members. But
Yeah, but then this is
quite nice.
Yeah, I think you want to avoid using yeah, because if you use explicit members, you've got to have access, you've got to have all this stuff. Yeah.
But for the user, wow, what a great experience. Like if you just look,
Yeah.
that's so nice to just say, oh, give me the members with this. Like now you're almost like the entity component system is almost becoming imperative again. It's
yeah.
It's like, yeah. Oh, it's pretty cool.
Yeah. So the only weird part is this. We don't know why. Yeah, that's not what I was expecting. Like you change something down here and then this changes.
Well, if you figure out how to do that prettier, I can also use it.
Okay.
In a different repo, but I don't know.
What's going on here is a good question for LeanProver Stack Exchange, I think. Like what happens when you stick something in a let? Like
how do you even ask that question?
with an example, you get a minimal repro of this.
What's the minimum repro?
You just want to transport something across an equality, and none of my mental models for how to do that match what Lean does. So, like, what's it doing? It's basically my question.
Cool. Well, I'm gonna end the stream.
Yes.
That was really fun.
Yeah.
Thanks. No one for watching. Cool. That's pretty on point. But yeah, I'll just upload to YouTube, and then more people do watch. Then weirdly, or bots. I don't know. Probably bots that are really interested in Lean.
Yeah. How do you think Alpha Proof worked?
Yes, exactly. Just watching our stream. That was
no.
Excellent. Yeah. Cool. See ya.